CSEC scholars, welcome to the live CSEC class. Tonight, we're going to be looking at the volume of prisms and focusing on, I would say, 4 special prisms. So you're going to find out which 4 we're talking about. And before we do that, let me play for you our schedule of live classes. So bear in mind, we have 5 live PEP classes per week and 5 live CSEC classes per week. And this is different from the hundreds of recorded videos that we have on the channel for CSEC math and for all the different PEP subject areas. So here is the schedule. Hello CSEC math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand. All right, guys, so these are pretty simple and straightforward topics. So volume of a prism. So let's get into it then, shall we? And let me invite my devoted scholars to join me. I have Asar, I have Imani, I have Ann.
Good night, Miss.
Are you there, Asar?
Hi, Miss.
Good night. Is John about?
Yes, Miss, he said good night.
Okay. Hi, John. All right, so let's get into it. I'm going to share the screen. All right. Does anyone know what a prism is?
Yes, Miss, it's a 3D shape.
It's a 3-dimensional shape. Is that it? So any 3-dimensional shape is a prism?
No, Miss, a prism is a rectangular. Miss, for example, the rectangular prism is like a rectangle, but it has more than one side than a normal rectangle.
It's a rectangle with more than one side.
And that's the best I can explain.
I don't think that's the definition of a prism. You want to look it up for me and read what you find?
Miss, it's a 3-dimensional shape with two identical shapes facing each other. The identical shapes are called bases. The bases can be triangles, squares, rectangles, or any other polygons. Other faces of a prism are parallelograms or rectangles.
Okay. So the prism is a three-dimensional object, and it has two bases. Or we could say it has a base and a top. That's one way of looking at it, right? But they must be identical. That's the important thing. The top and the bottom must be identical, and then they are connected to each other by straight lines. So as John mentioned, there's something called a rectangular prism. It has a special name. Do you know what the rectangular prism is called? Or do you know what the square is called?
A cuboid.
So the rectangular prism is called a cuboid. What's
So,
the
Miss,
square? What's the square prism called?
Miss, a cube.
A cube. And
Miss,
do you
can
know
I
what
read
this?
one?
Yes, sir. Do you know what the circular prism is called? So
Yeah. Oh, no, If I was going to say
A cylinder. A cylinder.
Mhm. And we also have triangular prism. All right, so the rectangular prism would look something like that. That's the rectangular prism. It's called a cuboid. The square prism, so all the faces are squares. All the faces have the same lengths. The square prism is the cube. The triangular prism is just called a triangular prism, to my knowledge. Triangular prism.
If I was going to say the pyramid.
Prism.
I think a pyramid is different.
Yeah,
Well,
last name I know for it, triangular prism. And the circular prism,
wait, but
What about
Miss, but doesn't a pyramid have triangles and oh wait,
no,
yeah.
the pyramid has an apex. It has a point at the top, and then so the pyramid would, it can have a square base pyramid or a triangular base pyramid. So there's
Okay.
a apex at the top. It's not the same at the top and bottom, right?
Yes, Miss.
Remember, so the pyramid is not a prism.
Yeah,
The prism must have the same shape at the bottom as at the top.
it's at the top.
Follow?
Yes, Miss.
Right. So the circular prism is the cylinder. And actually, as it mentioned, you can have any polygon, hexagonal prism, octagonal prism, once the same shape at the top, same shape at the bottom, and it's connected by straight lines, right? Straight lines down, that's a prism, okay? So what top is the base, or the two bases must be identical. Huh?
what type of shape is that?
Let me see. 1, 2, 3, 4, 5. So it's a hexagonal prism.
Okay.
But these are the common ones, and these are the ones we're going to feature tonight, right? The cuboid or the rectangular prism. Let me see. Is Asar back? Hold on. All right. So Asar is back. I just saw him and then he vanished. Hold on. All right. All right. So he's back. Oh, so good night, Jamani. Good night, Rosie. Good night, Zion. All right. So now the rectangular prism is the cube. So it might have different width, different heights. Okay. The square prism is all the sides are the same length. If this is 6, that is 6, 6. All the sides of a cube are the same length. That's a square prism. The triangle prism, the triangle can have any shape, any kind of triangle. Right angle triangle, scaling triangle, equilateral triangle, obtuse angle triangle. It doesn't. Once the same shape of the top base or the top is this identical shape of the bottom, and they are connected by straight lines. The circular prism is the cylinder. So we have a circle at the top, same dimensions for the circle at the bottom, and we have the height. Or it can be the length, right? So suppose it's turned this way, they can refer to it as the length, but it's the same distance that connects the top and the bottom of the prism. Can be called the height, can be called the length. So the idea, so we're looking at volume, right? And the idea behind volume, in most cases, is the area of the base times. That's the basic idea for volume. So volume is equal to area of base times the height. So then, in this formula class, we have all of these kinds of base. We have looked at area of the rectangle. We have looked at area of the square, which the square is just a special rectangle. We have looked at area of the triangle. We have looked at area of the circle. So we need then to find the volume is to determine what is the shape of the base of that prism and multiply that area by the height or the length between the two bases. So that's what we're going to be doing. So let's start with the simplest one, the rectangular or the square prism. So the cuboid and the cube. So is this a cuboid or a cube?
Cuboid.
So it's a cuboid, and let's say that's 6 meters. That's 4 meters. That's 5 meters. And this is also 6 meters. 4 meters. How would we find the volume of that cuboid? Anyone?
Mr. Volume. Miss. Oh, sorry, you go.
Oh, 4 times 6 times 5.
All right, so Asari is saying the volume would be, says length times width times height. So that would be, and multiplication is associative. It doesn't matter which one we work, which two we work first, right? So the unit for volume then is going to be cubic unit, since it's 1 unit times another unit times another unit. So that's unit cubed or cubic unit. So 4 times 6 is, work with me.
Miss, 4 times 6 is 24, and 24 times 5 is 120 meters cubed.
So 120 meters cubed. Now, what about the other 4s and 6s and 5s? What about those?
Yeah, Miss, they're still giving the same. Miss, they're the same measurements, so they wouldn't make a difference.
So they are redundant, right?
Yes.
Unnecessary. So basically, I just put them there tricky, right?
Yes.
So you're laughing at my silly little trick. So you're saying trick? How can I be tricked by that? That's what John is saying. But some persons will be tricked.
Yes.
Some persons will be tricked. Because there are some persons who see somebody is saying we have to multiply all the numbers. Somebody in chat is saying we have to multiply all the yeah, let me tell you have some students, you see, they think that
You have to use all the numbers before given.
you have some students think that once they see a number in in the problem itself or on the diagram, they think they have to find something to do with the number. They think they have to use up all the numbers. Just like I always say, you have some people, once you share out them, they think they must eat everything on the plate. They just feel good if they leave even one grain of rice. So you have some students who, any number they see in the problem, they want to use it because they feel like they're going to leave out something. So I threw in some extra numbers that are unnecessary. Problem. Maybe necessary for finding like the surface area, which is a topic we're going to do after we finish with volume. We're going to look at how to find the surface area of prisms. Now that you would need all the dimensions for, right? But for this need is the length, the width, the height. So know that this is the length is 6 meters. We don't need that this other length there is the same. Same height, 5. Same width, 4. We just need that one length, that width, that one height, and we find the volume. So volume is the space on the inside of the three-dimensional object, space available on the inside. So in other words, you're saying, if I were to pour some liquid, now name for volume is capacity when we're talking about fluids. If I were to pour something into that empty space, how much space would it take up? How much space would be available? That's really what we're saying, when we're finding the volume of the 3D object. We're saying how much space is available on the inside to pour some fluid into. And by fluid can mean liquid or gas. Gas is a fluid as well. Gas has volume. So that's it. Cuboid. All we need to find the volume of the cuboid is the length, the width, and the height. And we multiply them. And remember, the unit is cubic units. Whatever is meters is meters cubed, meters, centimeters cubed. So for the cube, which is a special rectangle with all sides equal. Oh my, that can't pass. No, I can't get away with that one. I have to do better than that. Little teeny bit better. For the cube, all the sides are equal. So if this is 4 centimeter width, the length is also 4. The height is also 4. So the volume of the cube, we can just simplify it and say the side cubed, because all the sides are the same. This is S for 5. Whatever the length of it is, just cube it, multiply by itself times itself. Here of 4 centimeters times 4 centimeters times 4 centimeters, which would give what's 4 times 4 times 4?
Miss, so 4 cubed is 64 centimeters cubed.
64.
Because 4 times 4 is 16, and 16 times 4 is 64 centimeters cubed.
Right, 64 centimeters cubed. That's correct. Imani, I want you to find the volume of this triangular prism. Same shape down the bottom, right? Same shape on the bottom. All right. So this is 15 meters. This is 10 meters. And this is 6 meters. All right, Imani. So what would be the volume of the angular prism?
Miss, it would be base times height times length over 2. So 6 times 10 times 15 over 2. Um,
The formula is correct, but the numbers are not correct.
we're going to have to find the Miss, are we going to have to find a missing side?
Mhm.
Oh, okay. Um, Miss, so Miss, is it a 6, 8, 10 triangle? Or
Mhm.
okay, so the base is
So see the
8.
right angle there. So once the right angle is there, the hypotenuse is 10, the base is 6. You know the other side must be what?
8, Miss.
Must be 8.
So
Because what?
Miss, because it's a special triangle.
All right. So 8
And
squared plus 6 squared is equal to 10 squared.
yes, Miss.
All right. So go ahead now. Find the volume.
So 8 times 15. Wait, no. 8 times height. That would be the 10. Miss, 8 times 10 times 15.
The hypotenuse is never the height. The height
Oh,
is the
yeah. Oh, so Miss, repeat what you said about the height. The height is the what?
the height is from the apex of the triangle to the base,
So
perpendicular. Hmm? You could call
Miss.
8 the height or 6 the height. It doesn't matter.
Okay, so 8 times 6 times 15.
Half base times height times the height of
Over 10. Over 2, sorry. Yes, Miss. So
5. So
8 times 6 is 48.
can we cancel?
Oh, yes, Miss. 2 into 8 goes 4 times. And 6 times 4 is 24.
Mhm.
And 24 times 15 is 360 meters cubed.
Okay. 316 meters cubed. All right, so that's the volume of that triangular prism. All right, Asar.
Yes, miss.
All right. Okay, so okay, Asar, find the volume of that triangular prism.
Okay, miss. The base of the triangle is 15 meters.
Is it? Is it a right angle triangle?
No, miss.
It's not. So we can't use half base times height. We don't know the height of triangle. So which other formula did cut to find the area of the triangle?
Miss sine. Um,
We don't know
Miss
any
Heron's
angle.
formula.
All right, so we can use Heron's formula. All right, so use Heron's formula to find the area of the triangle.
Oh wait, add up the 3 sides and divide by 2 to find the semi-perimeter.
All right. So the perimeter first would be 7 plus 13 plus
13 plus
15.
15.
So the semi-perimeter would be to divide that by 2, right?
Miss, so that would be 35 divided by 2.
35 divided by 2,
That's
which is
17.5.
17.5. All right, so that's the semi-perimeter. All right, so what's the next thing we do?
Then we put area equals
So the area equals
the square root, the semi-perimeter, bracket,
hold on, let me just put what it is. So it will be 17.5 times
bracket 17.5 plus 7 meters
minus
minus 7 meters and 17.5 minus 15 meters. And 17.5 minus 13 meters.
all right. So what do those give now?
Working it out.
So the 17.5. All right, so 17.5 minus 7.
Miss, the
Give me
answer
step.
is 45.
No, give me step by
Oh.
step. 17.5 minus 7.
10.5.
All right, so 10.5. And what's the 17.5 minus 15?
2.5.
Okay. And the 17.5 minus 13.
4.5.
All right, so multiply these 4 now together and that answer. So it's 17.5 times 10.5 times 2.5 times 4.5.
It's 2067.18.
So
0.19, sorry.
2067.9.
0.189.
Okay, 0.19. And the square root of that.
45.47.
So that's the area of this should be in meters squared, right?
Yes, miss.
So that's the area this is in meters to the 4th power because we multiplied 4 meters together. And when we find the square root, it's now in meters squared. All right, so the volume now, the volume of the prism now would be that area times the height of the prism. Height of the prism was 20 meters. So work that out.
$909.4 meters cube.
So 909.4
0.4 meters cube.
meters cube. All right, so let's retrace. So for the trapezium, we're actually going to look at 3 scenarios. The first one that Imani did, you're given a triangular for which you know the height of the triangle. So this was a right angle triangle. We could have called the 8 the height, the 6 the height, whichever. It's perpendicular to each other. So for that one, we use the half base times height because we knew the base. At first we didn't know the base, but we could find the base because it was a right angle triangle. And since the hypotenuse is 10 and one side is 6, the other side must be 8. It's a special triangle, the 6, 8, 10 triangle. 6 squared plus 8 squared is equal to 10 squared. So we could easily see that this must be 8, and so we could use the half base times height. For this triangle that Asar was given, we don't know the height. It's not a right angle triangle, it's a scalene triangle. We are 3 sides. So the formula that you can use to find the area of a triangle when you're given the three sides is Heron's formula. And Heron's formula says you add the three sides of the triangle to get the perimeter, and you divide that by 2, the semi-perimeter. And to find the area, you're going to find the square root of the semi-perimeter times the semi-perimeter minus each of the sides. So you subtract each of the sides from the semi-perimeter, and when you get those answers, you're going to multiply all 4 of them, and finally you find the square root of that. That's for the area, and the volume now of the prism, that the area of the triangular base times the height. So now the scenario which John is going to do is, if you are given you don't know the height, know the base, it's not a right angle, but you know 2 sides and angle between the 2 sides. So go ahead, John, find the area of the volume of this triangular prism. This is 22 meters.
Okay, so Miss, we already have the hypotenuse from the adjacent, so we're trying to find the opposite of the hypotenuse.
Not the hypotenuse, it's not a right angle triangle.
It's not.
It's not a right angle triangle.
Oh wait, Miss, we'd have to use Pythagoras' theorem.
We use Pythagoras' theorem for right angle triangles. This is not a right angle triangle. What's the formula? Remember, we did 3 formulas. We were talking about area of the triangle.
It's Heron's formula.
Half AB sine C. Half AB sine C.
AB sine C. Area of the triangle. It will cut Heron's formula because we don't know this length. So we have to use half AB sine C. So when we know the sides and the angle between them, we find half times the 2 sides times the sine of the angle. So go ahead, John, find the area of the triangular, and then we can multiply that by the height to get the volume.
Okay. So a half times 15 meters times 22.
No, not 22.
This time the 40 meters over. Time sine C.
Times the sine of 40 degrees. Okay, so tell me, so work that down for me now. What's half times 15 times 40?
Half times 15 times 40. That is 300.
Alright, so 300 meters squared. And what's the sine of 40 degrees?
Okay, 300 times.
Work out the sine of 40 degrees.
Okay, sine of 40 degrees. The sine of 40 degrees is 0.6427.
642.
7.
Or multiply by the 300.
300 times 0.6427. Next, that is 192.81.
192.81.
Yes.
So that's the area of the triangular base. So to find the volume now, multiply that by the height.
Come on. Okay,
What's What's the height of the prism?
The height.
The height of the triangular prism.
This 15 meters.
This is the height. The height of the prism is 22 meters.
Okay.
Multiply those for me and give me the answer correct to one decimal, please.
Okay, Mr. Answer the 4,241.8.
Meters cubed.
Oh, yes.
All right, so we've looked at the cuboid, the cube, and three different types of triangular prisms. Now, which other one we said we're going to look at? The cylinder, right?
Yes.
All right, so we're going to look at the cylinder. I'm going to give each of you a cylinder to find the volume. So the cylinder has what kind of base?
A circular base.
Circular base. So all you need to do then is find the area of the circle.
Yes, miss.
All right, right? Easy stuff.
Yes, miss.
Easy stuff. Easy stuff. All right, so this is our cylinder. And the height is 12 meters. And the diameter is 60 meters. All right, Imani, you're up. Find the volume of the cylinder.
Okay, miss. So the area, we're going to find the area of the circle.
So the area of the circle,
That's pi r squared.
pi r squared.
And the radius is half the diameter.
So the radius is
Yes.
16 divided by 2, which is
Miss, so that's 8 meters.
8
Now we
meters.
can continue. So,
Alright, so the area is
miss, so 22 over 7. Well, no, 3.14 instead.
3.14
Times
times
8.
8 meters times meters.
So that would
And
be
that is,
4 times 64. And
which is
miss, and that would give 200.96.
oh, 200.96.
Yes, miss.
Alright, so the area of the circular base is 200.96 meters squared.
And to get the entire prism,
So the
would
volume
multiply that by 12.
of this cylinder would be the area of the base times the height is 12.
12, miss.
So what's
So
how
that
much is
would give 2,411.52.
units?
Meters cubed.
Okay, very good. All right, Asar. So That's your cylinder, Asar. Find the volume.
Humus. The area of the circle is pi times radius squared.
All right,
The
so area
radius,
of the circular base is pi r squared, which is
which is, which is 9 pi times 9 times 9.
what you're using pi as.
Oh, 22, no, 3.14.
All right, so you're using pi in decimal form. So that's 3.4 times 9 meters times 9 meters. And that gives what?
254.34 meters squared.
All right, so that's the area of the circular base. And how about the volume?
That would be 34 meters squared times 24 meters.
The volume is what?
254.
Okay, 254.34 meters squared times what? Times the length or the
Yes,
height,
miss.
whichever way you want to call it. All right, and that gives what?
That gives 6,358.5 meters cubed.
All right. Okay. So are you ready, John? All right, John. So you get the last question.
Oh, that's it. That's the last question.
Yeah,
This is easy. Fun.
yeah. I told you it's easy.
Sorry.
There's no need to make things look harder than they are, don't it?
Miss, you make it sound like it's easy.
Yes. No, some people like to make things look harder than they are, and I think if something is easy, we should just accept that it's easy and move on with life. Yeah, accept that it's easy and move on. We don't need to take it. All right. So
Okay. Miss,
so
when
what's
have to
the
find the area, Miss, we have to Miss, the area is R is the radius squared.
pi times
This
the
is
radius
pi times
squared,
radius.
which is
Okay, Miss, the radius is 11
someone is
centimeters.
whispering beside you, John.
Yes.
Who is whispering beside you, Imani? Someone whispering answers to you.
No, Miss. Miss, no one's not whispering the answers.
Okay, no, I'm hearing someone whispering, so I just clarify. All right, so what do I do here?
Okay, Miss. Miss, the radius is 11 centimeters.
Hold on, John. I don't like how this cylinder looks. The cylinder look like it vexes somebody. Let me fix it. All right, so try and get us straight. A little bit better. All right. Okay, so what else I would know?
Okay, Miss. Since the radius is 11 centimeters, it'd be 3.14 because pi is 2.14 or 22/7.
Mm-hmm.
3.14 times 11 times 11
Mm-hmm.
because it's squared. Yes.
Mm-hmm.
And it's, when you multiply that, the area would equal to 379.94 centimeters cubed.
Centimeters.
Squared.
Centimeters square. So the volume of the cylinder then would be,
Okay. What's the volume now? Okay, so it should be 11 times 14 times
we already
7.
worked out the area of the base.
That's,
So just multiply the area of the base times the height of the cylinder.
okay, so 47.94 times.
7.379.
Oh, let's take the 7, sorry. 399. 379. 379.94 times 14. That is 5,319.16.
5,119.
Yes, miss. 3. Yes, miss. 0.16 centimeters.
Units,
Centimeters cubed.
centimeters cubes. Okay. So what if I gave you the volume and I wanted the height?
Area is the height.
If I gave you the volume and the area and I wanted the height.
Miss, what would that mean? That we divide the the area by the volume. The volume by the area.
Right. So the volume, the concept of volume for at least for prisms is the area times the height, right? Area of the base, whatever
It's
shape the base is, and area of the base times the height. So if we want the area, then we would divide the volume by it. If we want the height, divide them by the area. That makes sense?
yes.
That makes sense, don't it?
Yes. It's because
Yeah.
naturally, to get the volume, is we'd have to multiply the area times the height. So it makes sense to divide the volume by the area to get the height.
Right. And we could also use that to find the radius if push come to shove, right?
Yes.
If we divide the volume by the height to get the area, then all we need to do to find the radius now, the area by pi and then find the square root, right?
Yes.
Since the area is pi times the radius square. Divide the area by pi, find the square root to get the radius. So this is the basic concept, and this is for prisms. For prisms, because why I'm stressing the prism, remember for the prism, the top is the same as the bottom, right? Exact replica of the bottom. Top and bottom are the same.
Yes, miss.
If they
They're the
are
same.
not the same, you can't use that formula. It's going to have to be a different formula, which we're going to do, right? We're going to do like volume of the pyramid, volume of sphere, and those shapes do not have the same top and base.
Yes.
But for prism, where the top and the base are the same shape and they are connected by straight lines, which is the height, all you need to do is find the area of the base. If the base is a circle, you find the area of the circle and multiply it by the height. Base is a triangular base. Find the area of the triangle, whether you're going to use half base times height or Heron's formula or half AB sine C. Find the area of triangle and multiply by the height. If it's a square base, if it's a rectangular base, find the area of the square or the rectangle and multiply by the for prisms. For
All
prisms.
for
Only for prisms. So What I think we're going to do for the next formula class is find the surface area of prisms, and then we can go to finding volume of irregular three-dimensional shapes. All right? Yeah, that's what I think we're going to do. So that's the wrap.
It was
Why
lovely.
Imani always looks so frightened? Why Imani always looks so frightened when Imani, whenever you take center stage, you always look frightened.
Yes, it's because I'm not expecting to be so fake.
But by now you should expect it. I mean, come on. All right, now Imani, remember you promised to wake me up midnight
Yes, ma'am.
because we have a midnight class. We have a multiple choice class tonight from midnight. I mean, the time is getting less and less. It's supposed to be a 2-hour class,
Yes,
and
ma'am.
we're ending it in how long we took last time? I think it was an hour and 15
Yes,
minutes
ma'am.
or
So we
something
had
like that.
like 30 minutes left.
Yeah. So we're going to start at midnight and then we'll see how far we go, right? But
Yes,
we
miss.
do try to break it down and explain the items as best as we can for those who are struggling. We are going to do 60 items as usual. The paper that we're doing tonight is the 2010, January 2010 multiple choice paper, right?
This is
So
your
pardon me,
Let us think there's fractions.
if there's what?
This is just fractions.
Yeah, you have a couple of fractions in there. So it's 60 multiple choice questions. And we're going to go through all 60. So come over and join us. Go and get some snow so you can wake up back. Set your alarm. And yeah, come hang out with us at midnight. All right. So I'll see you guys then.
Okay, miss.
Bye,
Bye,
miss.
miss. Bye, sir.
Bye,
Bye.
bye, bye.
Bye, sir.
Bye,
Bye,
miss.
George.
Bye, John. Bye, Manny.
Bye, Manny. Take care, guys. All right. So here's our schedule, and hopefully I'll see you later tonight, or should I say tomorrow morning, midnight. Hello CSEC math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.